Hello all, this is Mr. G and welcome to Beating the State Test Round 3 Graphing Calculators. In this video we're going to be going over all of the released items, the released questions from the most recent state test where knowing how to use a graphing calculator, it might not be essential for every single one of these questions, but it's really going to make our lives easier. So let's make sure we know what we need to know before we get started with these questions. So what do we need to know? There's basically two menus we're going to be focusing on in this video as we go through these problems. The first is second, calc. We're going to use this menu to calculate a lot of different things about a function. We could use it to find the x-intercepts, to find a minimum or maximum value. We could even use it to find where two functions cross, where they intersect. The second menu we're going to be using is the stat menu. In this menu, we can sort of enter values and use the calculator to sort of draw conclusions from those values. But it's a lot easier to talk about these menus when we're actually doing some problems. So let's jump right in. Number one says, when graphed in the xy coordinate plane, which equations will intersect the graph of y equals 2 to the x in the interval 0 is less than x is less than 1? So basically, we're trying to figure out which one of these functions will intersect this function 2 to the x when x is in between 0 and 1. It would be possible to do this without a graphing calculator, but since it is a calculator problem, let's use this graphing calculator to our advantage. The first thing we're going to do is we're going to go to y equals and type in the function they're giving us in the directions 2 to the power of x. So 2, hit the caret symbol for the exponent, then we hit the x button. And we can graph that now just to get an idea of what it's looking like. And now what we're going to do is we're going to plug in each of these choices one by one and figure out, okay, which ones intersect, not just intersected at all, but intersect in this interval when x is between 0 and 1. Let's do choice A first. So I'm going to go down to y2, and it's 1 divided by x. Then we hit graph, and there's our two functions. Now we're going to calculate the intersection of these two functions by going to second, calculate, second calc, and going down to number 5, intersect. Now, to find the intersection, it's really easy. We're just going to move left or right to get close to the intersection. That's one intersection. I think that might be the only one here. And then we just have to hit enter, enter, and enter. As long as you only have two functions graphed at a time, you can just hit enter 3 times and it'll give you the intersection. So here we have an intersection with an x value of 0.64. That is in the interval we want. That's greater than 0, but less than 1. So A is going to be a correct choice here. Now let's try B. I'm going to go back to y equals, go to y2 and clear that out. And next we want to type in 2 minus the absolute value of x. To get to the absolute value, we need to hit the math button, go right to get to the number category, and number 1, ABS, that stands for absolute value. Then we type in x, hit graph, and we see what we're looking at. Now that we can see the picture of this graph, we notice there are two intersections. They're going to cross right there and right there. We don't care about the one on the left because we're only interested in intersections between an x value of 0 and 1. So since this intersection is going to have a negative x value, we're just going to ignore that. I'm going to go to second calc, hit 5 for intersect, and I'm going to move to the right to get close to the intersection we actually care about. Hit enter, 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 and we get an x value of 0.54. That's in the interval we want. That's between 0 and 1, so B is another correct answer. Now let's try C. Go to y equals, clear that one out, and this one is 4x. So 4 times x, we graph it. And now we can see the intersection right there. We go to second calc 5, move to the right, 1, 2, 3 times we hit enter. And we get an intersection where the x value is 0.309. So again, that's between 0 and 1. So C is also a correct answer. So far, they've all been correct answers. Now let's move down to what choice are we on? D. So x minus 1, x minus 1, graph it. Oh, and these don't cross at all. So we can just skip over that one. There's no intersection to find at all. We don't even need to go to second calculate. We just go to y equals, and now we're going to try the last one. Clear this out. It's 3x squared. Graph it. And again, we see two intersections, but we don't care about the one where the x value is negative. We're just going to find the one where the x value is positive. So second calc, 5 for intersect. Move to the right to get close to the one we're actually interested in. Hit enter till the directions, or rather till the calculator says intersection. And we've got an x value of 0.74, which means that's in between 0 and 1. So our answers were A, B, C, and E. Let's check it. A, B, C, and E, and we got it correct. Excellent. Number 2 says a function f of x is defined as f of x equals x squared plus x minus 6. We have to determine the x-intercepts, the y-intercept, the coordinates of any maximum or minimum, and intervals of increase and decrease. Enter your answers below. Enter only your answers. All right, so that's nice. We don't have to sort of justify our work or show any explanation. We just write the answers. Now, again, this would be possible without a graphing calculator, but it's a calculator problem. Let's use that to our advantage. Let's go to y equals, clear out everything for number 1, and then it's x squared. We're going to type in the function they give us, x squared plus x minus 6. And we graph it. Now that we can see the graph, the first thing they want us to find are the x-intercepts. Now there's a couple different ways to do this. I'm going to show you both, but first, let's make sure we remember all the names for an x-intercept. An x-intercept could also be called a zero, or it could be called a real root. So it's really important to know that vocab. Now the first way we're going to do this is by hitting second, calc, and then going to 0, which again, we remember means the same thing as an x-intercept. I'm going to hit enter. And now the calculator is essentially going to ask us where to look. The calculator is very good at finding the x-intercepts as long as we tell it where to look. So it's going to say, okay, give me a point to the left of the x-intercept, give me a point to the right of the x-intercept, and then I'll go in and find the x-intercept. The first x-intercept I'm going to find is the one over here on the left. And you can see the calculator is asking for a left bound. Essentially, the calculator is saying, okay, give me something to the left, to this side of the x-intercept. So I'm going to hit enter right there. Now we could have been more to the left or a little closer to the x-axis. It doesn't matter. And you'll see an arrow pops up. So the calculator is saying, okay, I'm going to start looking right here. Now it wants right bound. So I'm going to go to the right till we pass the x-intercept. Basically, the calculator is saying, okay, give me something to the right of this x-intercept you want me to find. I'm going to hit enter. And you'll notice another arrow pops up. So the calculators are now looking in this range for an x-intercept. And it says guess. I don't care about guessing. I'm just going to hit enter, and it gives us -3, 0. So the first x-intercept is -3, 0. But we can see there's a second one over here. Now we could do this exactly the same way. We could go to second calc 0, do left bound, right bound, and get our answer. But I'm going to show you a way using second calc intersect. But to make this work, we have to hit y equals and go to y2 and type 0. And when we go back to our graph, initially it looks like nothing has changed, but what we actually did, we actually graphed a line right there on the x-axis. And I can prove it to you by hitting trace and then going up. We can see that now we can move along the x-axis. That only works if you type in y equals 0 for another function. And what this lets us do, we can hit second calc intersect, because now that we have two functions graphed and one of them is the x-axis, we're essentially saying, give me a point that is on the x-axis and on our function, which would be the x-intercept. So I'm going to move close to this x-intercept, hit enter, 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 and then we get 2, 0 for our second x-intercept. Now remember, that only works if you type in y equals 0. It doesn't have to be on y2, it just has to be somewhere. So x-intercepts are done. The next thing we had to do are find the y-intercept. Again, there's a couple different ways to do this. I would actually do this without the graphing calculator, because I know if we have something written in standard form, the constant will always be the y-intercept. So the y-intercept here is going to be 0, -6. But if you want to use the graphing calculator to find it, you can just hit second calc value, and then it's going to ask you for an x value to type in. Essentially, the graphing calculator is saying, all right, you give me an x value, and I'll give you the y value that goes along with it. And to use this method, we have to remember that for a y-intercept, the x-axis, or excuse me, the x value will always be 0. So we type in 0, hit enter, and it gives us 0, -6. So two ways to get the answer there as well. What did we need to find next? We need the coordinates of any maximum or minimum. Well, we look here and we don't see a maximum at all because this side is going to keep going up forever. On this side, it's going to keep going up forever. So there's going to be no maximum, but there is going to be a minimum. The minimum will be the lowest point on the graph, which is right there, the vertex. And we can use second calc to find this as well. Second calc, there we go. And we want the minimum, which is number 3. We hit enter. And then it's saying left bound and it's going to ask right bound. Essentially, it's the same thing as finding the 0, but instead of going to the left and right of an x-axis, like left there and right there, a left and right of the x-intercept, I should say, we want the left bound and right bound of the minimum. Now, we have to be real careful here. Make sure we have something that's on the left side of the minimum and the right side of the minimum. Now, the reason it's so important to be careful here is because if you're doing the left bound, right bound for a 0 for an x-intercept, if you screw up the left bound and right bound, the calculator will tell you, oh, you made an error. You need to do that left bound, right bound again and try to do it correctly. But with a maximum or minimum, if you mess up the left bound or right bound, it's just going to spit out a number. So I'm going to be real careful that I'm on the left side of the minimum, hit enter, and then I'm going to be real careful that I'm on the right side. That's far enough. Hit enter, and again, we see these 2 arrows. So essentially, the calculator is saying, all right, I'm going to look and find you the minimum value of this function in between those 2 x values. I don't care about guessing. So we just hit enter, and we get x equals, all right, that's kind of weird. So the minimum is negative 5.00001. All right, I'm just going to round that to a negative 5. So we have a minimum at, what are the coordinates? Negative 0.5 and negative 6.25. And what else do we have to find here? Now we want the intervals of increase and decrease. To find when a function is increasing or decreasing, I know this is going to sound stupid, but I just imagine the function like it's a roller coaster and we're always going from left to right. So as we're going from left to right, we're going to be going down the roller coaster. Oh, how exciting. We're decreasing for that part of it. So this function is decreasing over what x values? Let's take a look. It's decreasing when x is, let's see. Well, this point, this x value right here, the vertex, that's sort of the dividing line. It's decreasing, gets to this minimum, then it starts increasing. So whenever x is less than that x value, that's when we were decreasing. So that's x is less than, what is that, negative 0.5. Negative 0.5. And then it's increasing on the other side of the vertex. So it's increasing when x is greater than negative 0.5. Because if we look at after the vertex moving to the right, we are increasing. We're going up. And was that all they asked us to find? Yeah, let's check the answers. Let's take a look here. X-intercepts negative 3.2, y-intercept negative 6, no maximum. That's the minimum we got. And oh, I wrote increasing and decreasing the opposite order, but whatever. As long as you label them, that should be fine. So decreasing when it's less than negative 0.5 and increasing when it's greater than negative 0.5. Excellent. Number 3. The table contains data about the fuel capacity in gallons and the weight in pounds for small motorcycles. And they give us this table of values, and let's see what they're asking us to do with that. We have to give an equation for a linear regression model for these data to predict the weight from the fuel capacity. Identify the variables in your equation. Then we have to justify how well your linear equation fits the model by discussing a scatter plot of the data and the correlation coefficient in assessing the fit of your linear model. And finally, we have to use our model to predict the total weight of a small motorcycle that has a fuel capacity of 6 gallons and discuss the usefulness of this prediction. All right, there's a lot going on in this question. So let's take this one step at a time. First, we need a linear regression model for all of this stuff for predicting the weight based on the fuel capacity. All right, so since we're basing everything off the fuel capacity, I'm going to make that our x value, and I'm going to make weight the y value. All the other questions in this video could have been solved without a calculator, but in my mind, there's really no way to do this by hand. Maybe you can do it and you're better than me, but I need a graphing calculator or at least some sort of calculator to do this problem. And we're going to be using the stat menu here. So I'm going to hit stat and we're going to essentially enter these statistics, this data that they're giving us. So the first thing we have to do is enter it into the calculator. So I'm going to go to number 1 after on the stat menu, which is edit. And then we've got L1, L2, L3. Basically, we've got these lists that we can enter these numbers into. So I'm going to make L1 our X, which is going to be 0.5, enter, and then 1.0, 1.1, 1.3, 1.7, 2.0, 2.1, 2.2, 2.5, and 2.6, entering all those numbers in for the X value. Now we're going to make L2 the Y values, the weight in this case. So that's 84, 131, 139, 145, 176, 212, 227, 219, 253, and 263. Anytime you're doing this in a calculator, always take a moment to double check that you entered all the numbers correctly. Because if you miss just one number, you're going to get a completely wrong answer. So always make sure you double check that you entered your values correctly. Now that we've entered all the X values and Y values into the calculator, we're almost ready to get a linear regression. But there's one thing I want to do before then. I'm going to hit the mode button and go all the way down to the second half of this screen to where it says, where is it? There it is, Stat Diagnostics. And I'm going to turn that on. Now that's going to be important later when we get our linear regression. Once that's on, we can hit Stat. And this time, instead of editing, because we already entered in all the numbers, we're going to go to Calc. And we're going to ask it to calculate a linear regression, which is right there, linear regression AX plus B. So I'm going to go down to, what is that, choice 4, and hit enter. And then it's asking us just to double check what we want. Do we want the X to be L1? Yeah. Do we want the Y to be L2? Yeah. Because remember, we put the X values for L1, the Y values for list 2. So we can just go down, leave that stuff blank, and just hit enter on calculate, and it spits out the linear regression. Now they wanted an equation here. So the equation is going to be Y equals, and it's AX plus B. The A value they gave us was 83.89, I'll round that to, X plus B. And the B value they gave us was 42.29. So we just used that linear regression to come up with an equation to represent this linear model. It also says identify the variables in your equation. So if this were the actual state test, I would be writing down, oh, X represents the fuel capacity in gallons and Y represents the weight in pounds. Let's see what we need to do next. It says justify how well your linear equation fits the model by discussing a scatter plot of the data and the correlation coefficient. Well, the correlation coefficient is this R value right there. And we're only going to get that if we turn the stat diagnostics on in the mode menu. That's why we did that before we found our linear regression. What R tells us is essentially how well this equation is going to predict or match the data in our table. And since we have an R value of 0.995, this means that it's going to be a pretty good fit because it's close to 1. So since this is close to 1, this is going to be a good fit. Now, obviously, if this were the real state test, we'd have to be more verbose in our explanations, but this is good enough for right now, just going over the problem. It also wants us to discuss a scatter plot in our explanation. Me personally, I just see this R value, this correlation coefficient, since it's close to 1, that means our equation is pretty much going to match the table and a scatter plot. So I would just put something like that in my answer. Since this R value is close to 1, we know it will match the scatter plot pretty well. But in case you actually want to see this on the graphing calculator, we can do that. We might not need this for the answer, but I think it's interesting. So let's talk about how to do that. We'd have to go to stat plot. So we have to hit second, Y equals, and I'm going to turn plot 1 on. So I'm going to hit enter on plot 1, turn it on, and then I'm going to check X and Y. So X, that's list 1, Y is list 2. And then we can actually hit graph and get a scatter plot. But before we do that, we need to hit window to make sure we can actually see it. So our X values, they were between like 0.5 and 2.6. So I'm going to make the X minimum 0 and the X maximum, I don't know, maybe 3. And then the Y minimum, let's see, the Y values went from 84 up to 263. I'm going to make our Y min 0 though, and our Y max 300. You don't have to use those exact numbers, but those are the ones I'm using. Then we're going to hit graph, and we can see a scatter plot. And we can actually see, yeah, this is pretty much making a line. So a linear model would be pretty accurate or a good predictor for this table of values. The last thing we have to do is use our model to predict the total weight of a small motorcycle with a fuel capacity of 6 gallons, and then discuss how useful that prediction will be. Okay, well, that's not too bad to do. We just plug that in. So it's going to be, I'm just going to do this right in the calculator. It's going to be 83.89 times our X value, which is 6 gallons, plus 42.29. Hit enter, and we get 545.63 pounds. Now we have to discuss the usefulness of this prediction, and I don't think this is going to be very useful at all. And you might be surprised to hear me say that because I just made such a big deal about how R is so close to 1, so it's going to be a good fit. But we have to keep in mind that this 6 gallons is way, way outside the range of X values we used. So I don't think this is going to be a very good predictor at all. So I'd say something like that in the explanation. Let's check the answers now. So we got 83.9x. Oh, so they rounded to one place instead of two places. I don't think in the directions it said round to the 10th anywhere, though. Yeah, so I think either answer will be fine there. And then the R value, good fit because it's close to 1. And they give the total weight as being about 546, and it might not be accurate because 6 is outside the range of data values. But this 546, it didn't say round to the nearest whole number in the directions, did it? No, so I think our answer of 545.63 is completely acceptable. And we're finished. As always, I hope this was helpful. If you have any questions, by all means let me know. Enjoy the rest of your day.